maintain the comfort level and the required patient care. So energy efficiency has become a key factor deciding the energy cost of operating these buildings. So today's program is energy efficiency in healthcare sector, and today's speaker is Mr. Engineer B.V. Suresh Babu. He is an accredited energy auditor of Bureau of Energy Efficiency, Government of India, and he is having an experience of 20 years in energy engineering. He has completed more than 700 energy audits in various sectors, and he is an energy auditor by profession and has been appreciated by Government of Kerala by its prestigious Kerala State Energy Conservation Award for his commendable achievements and contribution towards energy conservation and management activities in the state of Kerala. He is the co-founder of AutoTraction. It is a firm working exclusively on energy engineering and environmental solutions. He also holds various positions in different technical institutions. Like he is a director of Clean and Energy Technology Division in CISA, Center for Innovation in Science and Social Action. He is a fellow of Society of Energy Engineers and Managers, FEEM, etc. So he has also published various papers on energy management, low carbon schools, sustainable development, and science and technology. So today, here this program we are hosting is provided by IITMK, that is Indian Institute of Information Technology and Management, Kerala. So we have been, Energy Management Center have been conducting a series of webinars on various topics, and this is first of its kind program, and we have started this program on June 5th. So we have prepared a webinar calendar titled Energy Efficiency in All Walks of Life, from lamps to boilers, and the same is published in our website. So we have been conducting a series of webinars. So as this program is concerned, if the participants have any doubts during the webinar, so you will not wait till the end of the program. You can make use of the chat box in the platform. You can type the questions there. So your doubts will be noted by Energy Management Center, and Energy Management Center will compile the questions and get the answers from the speakers, and will prepare a FAQ booklet. This booklet will be shared among all participants via email. So I wish you all a very fruitful and interesting session, and thank you. So I invite Engineer B.V. Suresh Babu for giving the presentation. Thank you.
Thank you, Sandeep, and I welcome all participants to this presentation. Today, I have given the opportunity to present the energy efficiency in healthcare, and I have arranged this presentation in a way that how the energy is being used in healthcare systems, especially in hospitals, and how they are managing it, and what all are the opportunities in energy efficiency in hospitals, or you can say healthcare system. First of all, I would like to introduce some factors and figures in healthcare systems in India. In the healthcare system, basically hospitals are the backbone of the healthcare system in India. Usually, in 40 years back, we have healthcare is totally depending on the public hospitals. say government hospitals. But after a transition period in 1980s to till now, there was a huge investment on healthcare in the private sector. So in India, we have now a number of world-class private hospitals which caters the support system to the healthcare in India. As we all know, we are in a pandemic period and we are approaching a post-pandemic scenario and all, and the healthcare system is working all stretching their all abilities to support our nation to overcome this pandemic. Not even in the pandemic, almost all the disasters where the healthcare system supports. So, according to the World Health Organization, India is not a huge investor in healthcare system. In the healthcare system, we have something like around 860 beds per million of population. If we compare it to the other world average it is around 396, 3960 beds per million. That means we are far behind. So this is an opportunity for the investors to invest hardly on healthcare system. So if we are going to a number one economy, the like $5 trillion economy and all, in 2025 and 2030, we require a huge number of hospitals and the facilities, modern facilities and all. And of course, it is going to be an energy intensive sector. And there are a lot of people which comes to invest heavily on this. And now I will go to the Rahul. Can you go to the next slide? Okay, I can do it, right? Okay, fine, thank you. Okay, this is the scenario of Indian hospitals, and here we have three sectors of hospitals, like government hospitals in urban, and the government hospitals in rural, and the private or rather NGO hospitals and nursing homes. So if we see the total hospitals beds, we have something like around 1 million hospitals in hospital beds in India. If we considering all the hospitals, in the government hospitals in urban, rural, and all the private hospitals, and the estimated KWH per bed is actually a little bit less in rural government hospitals. It's around 150 units of electricity or energy. It's electricity plus thermal, 150 to 300. That is in the rural sectors of government hospitals, where the modern facilities will be little bit in the lower side. And if we consider this into the urban hospitals in government sector, this is varying from 750 to 1,500 units. And if we compare it to the private sector, it's around 1,000 to 2,000 kWh per bed per year. This is actually the estimate. And the estimated energy cost is something like around 4,300 to 8,700, something like 9,000 million rupees per annum. This is the situation, of the scenario of Indian hospitals. Now, Move to the next slide. So why we need energy efficiency in our hospitals? Why we need energy efficiency is in the commercial building sector, which includes offices, hotels, hospitals, retail shops, etc., is growing in a fast pace, as we all know. And as per the Central Electricity Authority (CEA), the growth of energy consumption in this sector is in highest at around 14 to 20%. It's actually fastly growing commercial building sector, and our hospitals are in that category, commercial building. If the growth continues at the present level, additional demand growth of for the power in the hospital sector would be around 8,500 to 10,000 megawatt per year. This would mean a capacity addition of around 40,000 megawatt in the 11th plant, that is current plant, just to meet the additional demand of the commercial sector. This is the requirement of and the need of energy efficiency in commercial sector, especially in hospitality like hospitals. And if we are taking into account the present power system of our nation is not adequate to meet this existing demand. So we have two options. One is add more power stations and maintain our growth rate. Second, if we have not such options available, then what we can do is bring in energy efficiency and energy conservation and support our power system to cope up with the demand. And there are both the peak demand and electricity shortages, because in hospital sector is working 24 hours 365 days. There is no off peak. Both our peak demand is going up, and the electricity shortages are a real life situation. We need to consider the energy efficiency come into our hospitality section. One of the key ways for managing current shortage and the future need of power is the efficiency enhancement and conservation of energy resources. And in this point of time, as we all know, in 2001 we have a Energy Conservation Act which enabled us to make conserving energy a mandatory affair. In this view, we are institutionalized the mechanism of energy efficiency through various measures which have identified the building sector as one of the key areas. The Bureau of Energy Efficiency, the statutory body under the Ministry of Power, has the responsibility to implement the provisions of Energy Conservation Act through its state designated agencies like Energy Management Center in Kerala, and they are fervently working for the last 20 years to bring in this energy efficiency component to the hospitality sector, and they had a lot of measures implemented all over this particular sector and bring in the energy efficiency. So now, the healthcare industry is the largest employees in India and is also the largest in terms of revenue, and its growth is something like around 3,642 billion by 2016. In Indian hospitals are increasingly become the global destination for medical and patient care. You see now, I have been told in earlier introduction, after 80s, our hospitality sector, hospital healthcare sector has grown in such a way that now we are the global destination. Even in Kerala, we are one of the global healthcare destinations in the world. We had a world-class hospital facilities, something like it has been connected with the health tourism also. So there is a corresponding growth of infrastructure to support the industry, resulting in an increased energy use in the hospitals. Energy use assessment studies indicate high potential for energy efficiency, nearly around 20 to 30% of the existing cost savings. Most of this potential to save energy has, however, not been tapped, that we all know. So, what are the major barriers? The main barrier on this inculcating energy efficiency and energy conservation in hospitality sector, especially in hospitals, healthcare, in the building, commercial building sector, is the low awareness among the owners and the facility managers on energy efficiency opportunities and approaches to harness the same. Because, as we all know, the prime business in this sector is the critical care management. If some criticality comes in, they will be least bothered on consumption of energy and spending on energy. Where always they can collect the energy cost from their clients. This is also an issue. And another one is the limited availability of in-house expertise for identifying energy saving projects and their implementation. This is another challenge, because these hospitals may not have a specialist person to identify all these energy saving schemes, so this is a barrier. And another one is a lack of in-house energy management organization structure. This is also a barrier, because there is no system available. Something like they have a lot of healthcare systems and quality systems, but there may not be a quality energy management system available in these units. So now we will come to the end use, how they use, what is the cost and all in the energy use in the hospitals. Hospitals are institutions for the care of sick and injured, and usually function 24 hours per day, all year round. There is no break. There is no holidays for hospitals. They usually consist of large buildings, and careful control of their internal climate is considered necessarily. Like the climate is not only having some cooling, but there should be quality air. That also has to be considered. Substantial amount of heat is normally generated internally by the occupants as well as the operating equipment. Hospitals also require standby electricity generators to ensure N+1 redundancy, a continuous and quality power supply in emergencies and critical operations. And the typical hospital building is designed for long-term use. It's actually an average lifetime is something like around 50 years if you build on hospital. During this period, the building is retrofitted and renovated many times. As we know, if new technology comes, new facility comes, the renovation will happen. Usually, once in 5 years, a total renovation, refurbishment will be happening in the modern hospitals. Reason for this includes the shorter life of technical equipment. As we all know, the development of new types of equipment with healthcare facilities, new regulations, new quality regulations, new healthcare regulations, new pollution control regulations, new energy saving technology which comes up once in every year or once in every 6 months or something, and the aging of the building itself. These all are the factors affecting retrofitting. And usually in 50 years, there will be around 10 times the retrofits will happen. Hospitals are large consumers of energy, having high bills of electricity and fuels. Although they may represent a small proportion of hospital energy cost, usually it comes something like around 3 to 8% of the total expenses of a operating cost of a hospital. This we may think something like around a lower side, and also you can recover this amount from the patients. Even then, this constitutes a significant component, estimated around 15 to 20% of the hospital operating and maintenance costs. Because if you take the operating and maintenance cost, it's really something like around 15 to 20%, because the energy cost, energy consumption will directly deal with the quality of operation in every hospital. And next slide. Hospitals purchase energy from outside in the form of fuels and electricity. Usually, for thermal applications, they use furnace oils, LPG, light diesel oil, gas to generate steam or generate hot water, and other thermal applications such as catering laundry facilities and some sterilization facilities and other. In most of the hospitals, fuel oil, mainly diesel, is mainly used for standby power generation, which are used for considerable period due to inadequate power supply from the utilities in many states of India. Usually, the average cost of generating one standby generator is something like around 30 rupees to 35 rupees per unit of electricity generates. And the electricity consumption depends upon the extent and the complexity of equipment which and services provided in the hospitals. As we all know, this is a complex building. It's not like when you audit or study a building, a government building or a commercial building or a hotel. The complexity of the hospital building is different, because you can find a lot of digital, highly sensitive equipment which usually used for healthcare systems. New hospitals often have proportionally more air conditioning with its associated chiller plant and more extensive ventilation systems to maintain healthcare facilities and comply with the standards. And these all are the reasons for intensive energy use and energy cost in hospitals. And usually, if we consider thermal, electricity, etc., around 90-95% of the total energy consumed in a hospital is through the power, electricity, grid power or solar or something they already have. And the 3% comes from around fuel oil for diesel. Diesel which is usually used for steam generation, for laundry, for sterilization, etc., etc. And 2% for LPG, usually used for autoclaves or kitchen applications. The hospital energy bought in is converted by a number of conversion systems into several internal energy streams to meet heating, cooling, and other medical equipment requirements. So the conversion efficiency loss is also there in the hospitals. So now we will discuss various energy streams in the hospitals. I have said we have electricity, which is used for a wide variety of purposes. Majorly, electricity consumed in the hospitals are HVAC systems, and then it comes lighting, air compressors, water pumps, fans, ventilation, etc. Other applications include laundry equipment, kitchen, ovens, geysers, and special medical equipment, autoclaves, and office facilities such as computers, photocopiers. So small things also matters. Utilities such as slaves, refrigerators, water coolers, etc. We will see how we can save. What are the opportunities to conserve energy and increase energy efficiency in these sectors in the coming slides. And now, after electricity, we have heat stream. You can say hot stream is used to form steam and hot water. Steam is used in kitchens and for humidification in HVAC and sterilization process. In addition, steam is used to transport heat over longer distances. If you want to have a centralized hot water system. In many cases, heat is transported from heat generating station in the form of steam and then converted locally into central heating or hot tap water. Oil or gas-fired boilers are used to generate heat and hot water. And compressed air is also another energy stream. Usually, compressed air is generated from operating compressors, and the source of energy is electricity. And but we will take this compressed air as an energy stream because we all know to generate compressed air is an inefficient process. Only around 10% of the total energy input is converted into compressed air. So we must be very careful to utilize the compressed air, precious compressed air. Compressed air can be divided into two main categories, namely medical air and technical air. Medical air refers to direct treatment of care, something like dental applications or some other cleaning application, etc. Example, including breathing apparatus and surgical tools driven by the compressed air. The medical compressed air is subjected to very high standards of for availability and quality. The technical compressed air is used for operating control valves, pneumatic valves, etc. And workshop applications and keeping containers under pressure for long life. So then, after compressed air, the other energy stream is cold stream. Mainly, take the form of chilled water, and is used for indoor air climate change control systems for cooling and drying the ventilation air. In many cases, cold stream is generated centrally by means of compression coolers. In combination with cogeneration, absorption cooling mechanisms, and are used for supplement compression coolers. So as we discussed, we have electricity, we have heat stream, we have compressed air and the cold stream. And now we will discuss the major energy end users of the hospital. The major electricity end user in a hospital is undoubtedly HVAC system. Heating, ventilation and air conditioning system is in average hospitals, it consumes something like around 40 to 50% of the total energy consumed. Maintaining the requisite indoor air temperature, air distribution and humidity levels for thermal comfort. Maintaining indoor air quality, particularly in the areas requiring prevention of infection. Building envelope design plays a very important role in the determination of HVAC capacity in a hospital. Other, we have lighting system. Lighting system is the major electricity consumer, next only to HVAC, something like around 10 to 15%. The requirement of lights in a hospital varies widely, depends upon the activity, time of day, and the occupancy level. Because even the amount of light requires for operation theaters is not same as the requirement in the lab or requirement in the corridors of the kitchen. The complexity can well understood from the simple fact that the building code in the National Building Code, that is the base code for the ECBC, which recommends implements level varying from 1 lux to 750 lux in operation theater. Sometimes in special operation theater arrangements, which requires around 10,000 to 50,000 lux in the tabletop. Okay, this is the use of lights. And now we have water pumps. Water is consumed in different sections in the hospital for various requirements. Most of the hospitals, water pumping system may account around 5 to 15% of the total energy consumption, and offers scope for reducing around energy consumption. Usually, our drinking water, sewage water pumping, chilled water, and condenser water, cooling water, hot water pumping. So, lot of water pumping in operation in the hospital. That is also a potential area. Now, this is the breakup of electricity consumption in a typical hospital. HVAC, it comes something like around 30 to 65%, lighting around 30 to 40%, water 10 to 12, and others like special equipment, lift, etc., on something like around 5 to 15%. Generally, lighting and HVAC applications constitute around 75%. So, if we are looking to save energy and increase efficiency and energy conservation, we need to concentrate more on HVAC and lighting, because around 75% of the total electricity consumed in a hospital is through these two areas like HVAC and lighting. So now we have the approaches. What are the energy saving approaches we are operating? The main approach is, as all we know, the best energy saving device which we have nearby with low cost approach is choice. All energy consuming equipment should be switched off when it is not in use. We all know this, but we all will not do this, or we will not make sure that this has been done. This can be done manually by hospital staff or automatically with special devices. This needs a thorough awareness to the hospital staff from the bottom to top, and also this message has to be transferred to the patients also, because usually in the wards and the rooms the patients use it. So we need to spread the message of the importance of switching off. Another one is maintenance. A number of energy efficiency measures can be carried out as part of routine maintenance procedures at no extra cost. Because the maintenance is a as usual business, as usual procedure. So we need to put everything in line so that there is no extra cost is being spent for this energy saving through maintenance. And refurbishment, energy saving measures can be extremely cost effective when planning for the refurbishment in the hospital. You may know in 80s and 2000, our best energy saving device in lighting was something like around bulbs, incandescent bulbs. Then immediately it changes to tube lights. Then it changes to CFL. Now it has come into what they come into LED. So the refurbishment activities in the hospitals always accommodate this type of innovations in energy saving techniques in lighting or any other system. Now, in thermal insulation, the thermal properties of the building envelopes are very important. As a well air conditioned hospital requires a temperature level of around 21 to 20 degrees Celsius throughout the year, but is limited to a maximum of around 26 degrees Celsius in the warmer months. In several European countries, regulations are usually in form of mandatory maximum levels U values, coefficient of thermal transmittance for the entire building envelope, including walls, foundation, roofs, and windows. But in India, this is being currently attempted by the ECBC, particularly for new buildings having a connected electricity load of 500 kW or more, or contract demand of 600 kVA or more. This complains the thermal conductivity specifications is mandatory, and you should make sure that these all are in line with the National Building Code and with the Energy Conservation Building Code, which has been come into force in May 2007. And in Kerala, now it is mandatory for all this. I think the 500 kW has been, the scale is reduced to 100 for the other commercial buildings, and this is mandatory in Kerala now. And now in ventilation for hospitals, it is not always the heat generator that decides the ventilation. Because if you are putting a air conditioner in a room, you should consider the other factors also. Usually in our home, if we put a air conditioner, a 100 square feet room, you directly put in 1 ton AC. Because where you need just to evacuate remove the heat. But in hospitals, not only heat which matters, ventilation also it matters. Because the ventilation is very important for its hygienic considerations. As indoor air quality is contaminated by occupants, some of them may be patients and the visitors and the activities in the hospital. It must be renewed in order to eliminate contaminants, odors, and pollutants. In India, NBC recommends 68 air changes. That means 100% air change per hour in hospital wards, and 15 to 25 air changes in the sterilized departments like operation theaters and the sterilization labs, etc. in the hospitals. These also we need to be considered, because this is not, we cannot blindly put some air conditioners in the even if you go for audit in some hospitals, in some but you can say some operation theaters or labs, you will find some split air conditioners installed. See how the split air conditioner will remove your air to 100%. Difficult. So you need a different system which is energy intensive, because it's very, not only you need to consider the heat but always to the ventilation also. And in lighting, daylight, as we all know, by far the most desirable type of illumination for human comfort. Design of areas used by patients should always provide by windows. Their size, orientation, position in rooms must provide sufficient light levels and should give a view of outside surroundings and the sky. This adds to a patient's feeling of contact with the outside world, which is important physiologically, psychologically, and in healing. Often in conflict, the above benefits are the unwanted effects of glare. Because if you bring in lot of daylight in the room, the glare will also come. That is actually not in a comfort zone. That is not a comfort situation. So you need to cut that glares also. And also, the daylight should not bring in heat, the solar heat gain. So overheating due to solar radiation has to be arrested. This, if not avoided, result in considerable discomfort for the patient and an increased need of cooling energy. For this reason, sunshades and blinds should be fitted to affect the affected windows. Usually, the orientation of the building matters. So, in temperatures, how to maintain? The maintain comfort levels of pension. Typically, temperature for the patient's recovery room is around 24, 26 during summer, and this value could be maintained around 21 to 30, 23 in the colder part of the year. When temperature discomfort is identified, it is usually more efficient to localize the sources of discomfort and treat these rather than to decrease the room temperature. This can be done, for example, by covering cold walls, erecting screens against cold drafts from the windows, window frames and badly positioned air vents, and minimizing air isolation and installing sunshades. And now, indoor air humidity. Indoor air should neither be too dry, which causes dehydration, nor too humid, which causes perspiration, and increase the risk of fungal growth. So the humidity shall be maintained in between 45 to 55 percentage in the patient rooms, and the temperature at 26 degrees Celsius normally occur in the patients and the recovery rooms. This has to be maintained in well in advance. Strict hygrometric controls are often only applied in rooms where conditions are more critical. That is, in operation theaters, intensive care wards, post-operative wards, recovery wards, and the labs, etc. Now, we will move to the how we will have a energy baseline and the benchmarking aspect. So, why we need a benchmark? Where are we and where should we going? That everybody should know what is our present status and what should be our target. What lies at the heart of this question is the belief that we should track how far we have to come in order to know how far we have left to go. In hospitals, measuring an energy performance is sometimes easier said than done. And if we say some benchmarks and all, if you looking from the outside, it may look very easier, but it's not so easy. Not only is the baseline needed to be benchmarked from, but a clear destination is also needed. In majority of hospitals in India, the energy managers do not have an easy way to gauge the energy performance for their hospitals, or for that matter, a destination to go for. Now, we can bring in two type of indicators, mostly internationally accepted by the Leonardo University in 2008. And the annual energy consumption per meter square per hospitals per building area. That is KW is per meter square per year, or KW is per IP bed per year. So these are the two indicators for the benchmarking. The energy auditor or the energy manager can wisely choose which indicator they can preferably bring in for their hospital. It is important to bear in mind that these indicators are based on technical characteristics of the building. If sufficient data is generated and compiled, then it is desirable to compare hospitals on the basis of energy consumption, both per bed and per square meter. One difficulty that stands in the way of benchmarking is the degree of outsourcing in the hospital. For instance, some hospitals contract out their catering and laundry services, which leads to a lower energy consumption by the hospital itself, and thus they have lower baseline and benchmarks. The outsourcing has to be normalized when you are bringing in this one. Okay, now we are talking about built up area into consideration. The hospital management needs to decide which area of hospital building are included in the benchmark or not. Example, outdoor gardening, car parks, roads, corridors and equipment floors. Secondly, how much of the hospitals built up or carpet area is air conditioned or non conditioned in the real situation. When taking bed into consideration, hospital built up or carpet area per bed is a critical factor. This factor is determined by the type of hospital and by design criteria of its construction. One needs to take into account the trend towards higher quality of healthcare and greater privacy for the patients, which may lead to a lower number of beds per room and thus a greater number of square meters per bed. Secondly, many hospitals have combined metering of energy consumption for outpatient department and inpatient department. Therefore, for an effective benchmarking, independent sub-metering of two may be essential. Benchmarking approaches. So again, earlier we have seen what are the benchmarks available: kWh per meter square per year and kWh per bed, IP bed per year. And now we can have some other approach. We can have internal benchmark or and the external benchmark. Why we need an internal benchmark? Where energy performance of a building is compared against its own previous performance over a period of time. This approach is typically used to compare performance before and after retrofit measures have been implemented for energy saving. And the external benchmark involves comparison of energy performance of similar buildings against an established standard or baseline. This is typically used to set performance targets for the future. Now, benchmarking assists in initiating an in-house energy saving program or a macro level energy efficiency program. It determines how a building energy use compared with others. This immediately helps the management in identifying saving potentials. It facilitates the management to set targets for improved performance and monitoring them on a continuing basis. In facilities, the building owners gaining recognition for exemplary achievements in energy performance like energy efficiency awards. It assists the service providers to communicate energy performance of the building in terms of typical versus best practice benchmark. It helps utility companies to combine energy data from various buildings and track energy use and its trends. So now we will discuss the opportunities available for energy efficiency. So first we will, as we have discussed earlier, around 75% of the total energy is used in a hospital is for HVAC and lighting. So we will now first discuss on space cooling and heating. So what is space cooling? Most managers recognize the importance of having an effective cooling and heating systems to keep patients and staff comfortable. It is often possible to reduce energy wastage while improving internal comfort conditions at the same time. Setting appropriate temperatures, ensuring that cooling and heating component and controls are operated and managed correctly can help reduce costs. In fact, it is possible in many hospitals to save up to around 30% on cooling and heating costs through the implementation of energy saving measures. So the first thing is eliminating energy waste does not have to compromise on patient comfort. This is very important because whatever you do to set things on this space cooling and heating, the first thing comes to mind for the manager has to be the comfort and the quality of air, quality of the space where the patient and the bystander sit. And another one is obtaining feedback. Encourage staff to report any areas that are too hot, cold, and dirty. Investigating problem areas where which can help to identify operation and maintenance issues. If these issues are addressed, the hospital staff and patients are less likely to adjust their temperature by operating windows while heating or cooling is on, or bringing in portable electric heaters or fans. Therefore, in order to maintain appropriate internal temperatures, the temperature setting should be in accordance to the activity taken place in the area. The good starting point is to know what NBC says, National Building Code says. Recommended temperatures for specific area in the hospital as per the National Building Code is given. For the operation theatre, the temperature should be around 17 to 27, and the humidity shall be around 45 to 55. And the recovery rooms, it should be 24 to 26. Patient room also this 24 to 26. So first of all, the first thing for the energy manager or the facility manager is to understand what is our set points. So I am set this thing and make sure that it is not going below that. So understanding these set points are very important, and this has to be done with the feedback from the through the staff which is employed to interact with the patients and patients. And now check controls. Some signs of poor controls in hospital include cooling, heating being too high and not enough. These all are very important. If it is cooling, if it is hot, very, very hot. Because of the thermostats located where sunlight, dots, or radiators or equipment affects reading. So if you locate your thermostats near a heat generating area, it will not sense the space. So the strategic location for the thermostat for the air conditioning system is very important. Thermostat being set into minimal level for cooling or maximum level for heating. Because of the staff believes this will make the space cooler. It will not, because thermostats are not human. Whatever human given fed into the system, they will respond. It does not. It simply results in overcool or overheat. Cooling, heating being on in unoccupied areas, because timers and thermostats are not set correctly. Usually in the corridors where you are not intended to cool, possibly may have some good cooling. Wherever you are cooling in the space, it has been leaked into the cooling. Always the heat will gain in the colder area. So you should be thoroughly check the controls which used for the air conditioning system. Check control thoroughly ensure system operating hours match the time when heating, ventilation, and cooling are required. As needs vary throughout the day. Fit simple time switches in small spaces. This is very simple. Such as treatment and consulting rooms to automate this process. This is very important because people's primary business is not to save energy. So you just put some controls which automatically saves things. If you take this controls, check controls, the first thing keep it into mind is patient's welfare. That comes first. So seek further guidance before turning cooling or heating up or downing. So obtaining feedback through employees, your nurses, your doctors, your housekeeping staff, from the patient point of view, is very important to fix how you check your controls. And next part is zoning. So you should be very much aware that which part of your building is to be conditioned. The hospital buildings equally have areas which different time and temperature requirements, such as in waiting areas or in the individual private rooms. This can be problematic when you where only one overall heating or cooling control is there. This is very important because you should zone it. There should be a categorized zone, and you should know where you need heating, where you need cooling, where you need this temperature, that temperature, etc. So this is very important. The extra control often results in increased comfort for patient and staff and saves money as well. So controlling is one part, and zoning, intelligently zoning, is very important. And another one is keep the air conditioned air in. Easy to access to hospitals is imperative at any time of the day or night. However, during summer months, open doors allow cooled conditioned air to escape the hot air to the enter. The thermostat then senses the temperature decrease and automatically switches on cooling, which may unnecessarily, which is absolutely not necessary. And where it's possible, two sets of doors should be having automatic control to increase case of access to help keep the air conditioning in. So when you get into a patient room or a now, and if you open the door, of course the hot air will ingress into the room, which is actually inefficient. So you should take some care, like automatic window, or door closers, air windows, some air curtains, etc. And another one is localized control. You should the thermostat radiator valve, that is TRV, is a simple control valve which with an air temperature sensor used to control the heat output from a radiator by adjusting valve flow. And correctly fitted and operated TRV can provide efficient temperature control in areas which have different usage patterns, such as treatment and consulting rooms. Upgrade controls is another opportunity in saving energy in space cooling. Many existing systems have all inefficient time and temperature controls, so that has to be upgraded when you are considering for refurbishment and renovations. So an optimal start controller learns how quickly a building reaches its desired temperature and bringing cooling heat on at the optimum time prior to building occupancy. So again, depending on the weather is also plays very important part if you use the controls. So for the space cooling, HVAC, the cooling system, these all are very important. Eliminating energy wastage, obtain feedback, check controls, zoning, keeping the conditioned air in, keep system clear and unobstructed, localize control, upgrade controls. We move to the next slide. So now, energy efficiency opportunities in ventilation system. So our mantra shall be safety first ventilation systems. So this is very important. Safety should be come into first part. So safety, how safety is important in ventilation systems. The use of ventilation for infection control is paramount, so that seek a professional advice before making alterations into a system. Because if you are dealing with some infectious diseases or other type of contaminations, safety first is the first priority for the ventilation systems. Ventilation systems for clinical areas in hospitals differ from those of most commercial buildings in malls and so on. In one critical aspect, they need to use full fresh air, no recirculation. This can create very high energy demand and is expensive to operate. This is very important to keep it in mind, the safety first. The quality of air which you use and the quality of air changes which you do. It is therefore important to distinguish between separate non-clinical areas such as administrative rooms which do not have this constraint. And some further energy efficiency measures may apply to this. In general, air should flow from clean to natural dirty area within a hospital, and outer grills should be sited at locations that do not present a health and safety risk. Now, we will move to the another one. Safety first is very important. Whatever you are going to do with the ventilation systems, any energy efficiency or quality efficiency, the safety should come first. Second one is how effectively you utilize natural ventilation. It's very important to make use of natural ventilation. It is very simple. Natural ventilation cooling relies on natural airflow between openings on opposite sides of the rooms of the building. On the rise, warm air being replaced with the air sac in through windows or some vents. It may be possible to use windows and doors to provide good levels of natural ventilation in some areas within a hospital, allowing mechanical ventilation to be switched off or turned on to save energy. So this is very important for making sure that your natural ventilation is in proper condition. And another one is at a temperature dead band that you are seeing at the band, the schematic, the band is given. Do not let heating and cooling operate at the same time. So that is very important and a sensible thing too. If you are using a air-conditioned room and you put a autoclave inside, this is not good. So you should know where should you put your how you set your heating parts and cooling parts. This is very important. Do not let heating and cooling operate in the same side. This can be avoided by setting a temperature dead band, a wide gap between temperature at which heating and cooling cut in. For example, in a hospital, the heating may set into switch off when a temperature of 19 degrees Celsius has been reached, and the cooling would not come into until temperature exceeds 24 degrees Celsius. So in 1920 rule, it is actually relative. Whatever the professional healthcare team suggests, you can make it. But take advantage for that also, and create a dead band for you and maintain the stuff. So you see, this dead band is given for 19 to 24 degrees Celsius. Another one is maintenance system components. Energy components consumption by the HVAC system is something like around 45 to 65%, can increase substantially if regular maintenance is not done. It may be in the terms of dirty or faulty fans, air filters, air ducts, and components directly affect system efficiency, increasing running costs and risk of breakdown. The performance of all systems should be reviewed annually and replacement parts ordered as necessary. Always consult a maintenance specialist. That is very important. So another one is mixed mode systems. Some hospitals use known as mixed mode system, which uses combination of both natural and mechanical systems. The building that uses natural ventilation, heating and cooling where possible, and mechanical ventilation only when needed. There are various advantages to this system. Mostly, the building comes more adaptable to the wide range of requirements. Another one is the equipment have more control over their environment. Another one is hospital can cut down the energy cost spent. And there's frequently someone believes that turning air conditioning thermostats at low as they go cools the building more quickly. Usually, if we put on our air conditioner and set our temperature band at lowest, say 15 degrees, 16 degrees Celsius, we believe that the room will cool faster, as we believe, because this is the lowest setting. But what is the reality? The reality is the temperature drops at the same rate, but area overshoots. Then overshoots. Using more energy than necessary and creating a discomfort for the staff and patients. If controls are not coordinated, the temperature could even go low, even go low than what we desire, enough for a heating system to be switched on. Both systems then operate at the same time. So this is not good that if you start your air conditioning system at the lowest, no, this is not a energy saving step, or actually you get more cooling. So how we can do? Set the thermostat correctly. If you want 26 degrees Celsius, set the thermostat at 26 degrees Celsius, not at 19, and then you convert it into 26. Set at 26 and educate the staff to dispel this noise, because usually your patients, your guests will disagree. You just tell them what really happens. If you lower your thermostat, it will not give you a good cooling rate. So this is very important. And you can do some tricks also. You can protect your thermostat to prevent tampering, to reduce the set points wherever possible. This is actually possible in your remotes, in your remote controls. It is possible. So you just fix the lowest bands and allow the system to operate. To save energy and increase comfort, it is better to reduce the amount of heat produced in the area than to raise ventilation rates. If you are concerned that your system is not operating correctly, or if the staff or patient complain about drops from the ventilation fans, talk to your maintenance specialist. This is very important, because these all are coordinated effect. Your maintenance specialist, your system operator, and the beneficiary all should give proper feedback so that the system can optimally operate. And another one is installation of variable speed drives for variable speed operation. Fan do not need to operate at full speed when if you doesn't need such flow. At lower flow, you can reduce the speed of the fan. There, automatically you can control the speed of the fans by using variable speed drives, or you can say variable frequency drives. The reduction in speed saves energy, and there are corresponding heating and cost savings also. Now, the important one is building energy management systems. Possibly almost all the modern energy, almost all the modern hospitals have energy building management systems. So you just input energy management, energy authoring, and integrate energy into building management system, and build a energy management building energy management system based on a network of controllers. for different feedbacks, and you just connected to the centralized energy management system through your energy manager, definitely it will save energy for you. BEMS can effectively control your chiller, your ventilation system, your HUs, your pumps, your lighting system, etc., etc. This is very important. So, in the ventilation system, as I said, safety is the first priority. Natural ventilation, temperature band, and maintenance of components, mixed mode systems, variable speed drives, and building energy management system. These are very important to take care when you are looking for the energy efficiency opportunity. In hot water system, now we will move into the hot water system. In hot water system, not only energy we need to consider, we need to consider saving water also, because in the water itself have some energy in it, because we need to pump. So pump energy is inbuilt in the water. A drop of water you waste will directly affect your energy efficiency. So you can consider some saving devices like tap restrictors. Tap restrictors provide equal flow at number of taps in the washrooms and can reduce water flow by around 15%. And push taps, these only operate when you press. Turn off when after you taken back your hand for a brief time period, and ideal for areas which tap may be left running, because usually in some common areas, washrooms and all, patients or bystanders or the guests will forget to close the valve. So in that point of time, you can use this push taps to save water. Shower regulators and water efficient showers. This is very important. In showers use less water than you use a bucket for bath, taking a bath. Showers usually save something like around 20% of water you consume. And another one is infrared controllers in the common rooms and all. You can use this, and it's actually energy consuming stuff, but it can save water from 5 to 15% of the per water tap per year. So taps that total toilet flush mechanisms fitted with infrared controllers are a good, particularly a great idea, because they also reduce the opportunity for spread of infection. Because usually when you use your washrooms and toilets in commodes in hospitals, there is a chance that, because there is a physical contact in between the seats and the patients or the bystanders, there is a chance that the infection will come down by touching it, touching the walls and all. So this is very important for rushing, controlling the infection. So now another one is the efficient supply of water. So you need to isolate hot water and another normal water taps from its source. Consider installing a point of use of instantaneous water heater in such cases if you need a continuous hot water system. This can extremely economical where hot water demand is intermittent, yet essential such as for hand washing and all. Now, regular maintenance of optimum performance. So, as I said, regular maintenance of systems, electricity using. You have to maintain your taps, your toilet commodes, your showers, your pipes, joints, etc., for simple leakages. Each and every drop, if you collect it, is actually a huge loss in terms of water. So, maintain a water service including taps, storage facilities, pipe work, etc. Check for water vapor and then check for evaporation through tanks, flood due to damage in your flow control valves, etc., etc. So these are very important to check. And another one is very important. It's actually run an awareness campaign, encourage staff to and visitors through posters, some videos, etc., etc. The importance of saving water and the importance of potable water and the environmental issues, etc., etc. And another one is the hot water system schemes and the boiler maintenance, pipe works, etc., has to be carefully done to save water. So these all are very important. Energy efficiency opportunities in hot water. Hot water equipment has to be maintained well, efficient supply, regular maintenance of optimum performance, run an awareness campaign, maintain boilers and pipe work. Now we will move to lighting. As I said, around 25%, up to 25% of the total energy electricity consumed in a hospital is for lighting. Again, here also, switch off policy is very important, very important. We need to switch off whenever it is not in use. Effective lighting is essential for healthcare staff to carry out its work properly. Yet it is possible to achieve significant savings in this area and improve the quality of lighting environment. Lighting can account over 20-25% of the total energy consumed in a typical hospital. Good lighting design can reduce cost by effectively utilizing daylight and the artificial lighting. And it's say we can have a system like make a member of staff responsible for going around at set times during the day to check for lighting and assign this in alternate on and only every staff assign this as a socially responsible activity and they will directly go there and whenever they see a light switch on with no use, they can switch it off. And another one is label light switches. You should know the which light and which switch it is. Usually what you do is you don't know the proper switch, which switch is for which light. So you switch on all lights and at the end of the day you'll find on light which actually you want and you will forget the others to stop. So effectively you can switch off the light if it is labeled. So it's very important to label each and every switch it goes where. This is very important. And the key area of security lighting, including pharmacy areas, stores, laboratories, essential accommodation, shall be labeled properly for this one. Maintenance is very important. Without regular maintenance, light levels can fall up to 30%, accumulating dust and other decoloring, etc., etc. So you need to maintain it, clean the fixtures regularly to get good efficiency of lighting. Install low lighting, energy lighting, like replace all your tubular fluorescent lamps with LED, which is termed as energy efficient. So whenever you have an opportunity to replace one of your tubular or incandescent lamp, you just replace it with a low energy lighting, which definitely give you more light and a comfortable light and also less energy. And usually the another one is installation of your existing inefficient lights with LED is actually now got a good advantage on pricing as well as its efficiency. And another one is switching in parallel. What is that? Hospital tends to leave to have a lot of windows, particularly on wards and in consulting areas. This provides a good opportunity to maximize savings. Wire lights so that those closer to windows can be switched off, while the rest remains on with separate controls. This is called switch in parallel. So you can have a good control. If you even want to switch it off, if you don't know where the switch or it is far, you can bring in these switches into the what you can say nearby the window. And another one is occupancy sensor, which ensures light only operate when there is a need. If there is no need, this automatically switch it off. So occupancy sensors can be considered in the common areas, like in the washrooms, in the corridors, etc., in the office areas, toilets, storerooms, where the light, sound light, always make the most of natural light. Research indicates that increased daylight in patient room may ease post-surgical pain, decrease the use of pain medication, and reduce the length of stay in the hospital. This is actually a beneficial stuff for the patient, possibly not for the hospitals, because if you reduce the stay retention time in the hospital, definitely the bills will come down. But again, you can market it with a lot of new patients coming. Lighting design is a complex, and many of the examples given here are general guidelines, appropriate for reception areas and other common rooms in healthcare units. Some tips will not be appropriate for special areas, so always seek advice before making a change to your lighting in your hospital. This is very important because these are general things which we found in the typical hospital rooms. Now we move to office and small power equipment. These all are very important. Around 5 to 15% of the total energy will consume in this one. And where equipment is left on unnecessarily, there are opportunities to make significant savings. Switch off all equipment which not in use and enable power down mode. This reduces the energy consumption and the heat produced by equipment, lowering cooling costs and improving staff and patient comfort. Lifespan of this equipment will also extend and the risk of breakdown reduced. Use low energy sleep functions on computers, printers, and copiers. Consider energy star labeled equipment when you are going to purchase any office equipment. Remember that the entire staff are aware of switch off policy. It should be written and displayed in the areas where effectively which can communicate to the staff and the guests. The cost and environmental benefits of doing such switch off program, the switch off policy, it has to be well written there. It is important to get policies endorsed by senior management. That is very important. That is what I earlier said. Senior management interaction in the energy management is very important. So it should be signed by the top management, the policy. And now we will move to the another area, which is cooking. Which usually you can say kitchens. There also, where we use LPG mostly, raise awareness among the kitchen staff, where we can make aware them that do not switch on too soon. Actually, if you are planning to prepare a dish and it doesn't require to switch on the stove earlier, it just switch on whenever it requires. Most modern catering equipment reaches optimal temperature quickly. There is no need to preheat it. Label equipment which is preheat time, because you can put the preheat time for the baking equipment or some other pans and all. You are to write so that the operator will be aware on the timings which he or she can operate the equipment. Avoid using catering equipment to warm the kitchen space or staff available in the window. Switch off heating and cooking equipment immediately after use. Avoid overfilling pans, kettles, etc., which definitely reduce your energy efficiency. Keep fridge and freezer doors closed and be forced at manufacturer's recommended intervals to save energy and prolong equipment lifetime. Always, if you go inside the kitchen and see the refrigerator, it will be full of ice, something like igloo. So you should not allow that. So it always help the kitchen people to defrost it regularly after the operator guideline. Switch off equipment light and exhaust fans when they are not being used. This is very important. And another one is procurement of equipment which with running cost in mind. Because whenever you procure a gas-fired equipment, which is more expensive to buy than electrical or steam equivalent, savings made on running costs make an alternate option. Equipment that automatically switch off, such as fan sensors, valves, can save more energy cost. Select ovens with large double-glazed view windows to reduce the need to open doors to expect insect some contents. When purchasing the catering equipment, fridges, freezers, etc., always keep it in mind that energy efficiency star labeling of B is there, and you are purchasing 5-star or more, 5-star rated equipment only for the kitchen domestic applications. And another one is heat recovery. Consider large volumes of warm air are expelled from kitchens. As we all know, there will be exhaust systems. Many managers do not realize that heat can be recovered from this by using heat recovery devices like recuperators and all. An air to water recovery system is often the most effective method of recovering heat because it can preheat hot water, providing a year-round preheated water for your hot water application. This definitely saves energy. And maintain kitchen extract ventilation. Ventilation units, extractor, hood, grease filters should be kept free from dust and grease and cleaned it at regular intervals. As you always know, if you are going inside the kitchen and if you see the hood, it will be something like black, viscous liquid placed in the filters and all. So you should clean it. Regular cleaning of ventilation system can increase the efficiency as much as around 50% of the compared with unmaintained systems. This is also reduce the risk of breakdown and increase the energy efficiency. So this is very important to clean the filters, clean the hood, etc. regularly to maintain the flow as per the OEM. And another one is monitor with the submeters. Submetering in kitchen can provide an extra incentive for the staff to be efficient by showing how energy is being used by the facility and how subsequent efforts had paid off. Catering in hospitals is at times outsourced, so there is the additional benefit of allowing for budget allocation and charging it to take place. So now we will move to the laundry, which is also an energy intensive part of a hospital. Laundry facilities are extremely energy intensive, with an average of 3 kilograms of dry laundry per bed per day is expected in big hospitals, typical hospital. So the laundries become big consumer of steam, which requires hot water for washing these clothes. They may account for as much as 10 to 15% of the hospital's energy consumption in modern hospitals. So the in laundry, we should make sure that the water is also be conserve. We can consider some points on how can save energy in laundries. Most steam heated laundries will generate excess low grade heat that can be conveniently reused elsewhere across the site. Water recovery by recycling the rinsed water from washer extractor is proven means of reducing water usage. Uh, Total water recovery is becoming more acceptable and should be investigated, because we should not do it for the dryer or washing machine. We need to consider the total recoverable water, so that you need to conduct a water audit in the laundry, so that you can save a lot of water and reuse it. Heat recovery by heat exchangers from hot efficient effluent is standard practice and can be used for all type of machines. Consider combined heat power CHP or cogeneration system, which might be viable for many sites, for the huge consumers, that can be incorporated in the hospitals. So now we will move to specialist equipment. This is very critical and very important equipment in a hospital. Specialist nature of a hospital environment means that there is a significant amount of energy intensive equipment such as medical fridges, mortuary and pharmacy cold stores, laboratory equipment, X-ray, CT scan, MRI, etc. And another one is portable medical equipment, which something like your ECG machines, etc., etc. There should be a procurement policy, energy efficient procurement policy for this, where choosing the most efficient equipment which will reduce energy use and heat gain is very important. And raise the awareness of energy management techniques among the staff to switch off devices when they are not being used, or make use of built-in standby or power down modes. And also another one is building design. Deal with the heat gains generated by medical equipment in the context of buildings overall design strategy. For example, instead of installing air conditioning for an entire department, considering local comfort cooling that can be used and required. Always check with an expert before switching it off or altering controls of the specific equipment, because this has to be consulted with your biomedical engineer, so that the performance of this one is very critical than saving energy. And another one is refrigeration equipment. This is also very important to energy consumption of refrigeration equipment, which usually used to store your medicines, etc., etc. One is defrosting. Follow the manufacturer's recommendation to save energy, prolonged lifetime equipment. Defrosting is very important. Maintenance. Check door seals on cold rooms. Fridges and frozen stores are replaced if damaged. Keep condensers and evaporator coils clean and free of dust, and check systems have the correct amount of refrigerant. That is very important. You have to see that the maintenance practices are going well in as per plan. Temperature control. Maintain controls of this equipment, like refrigerators, freezers, etc., etc. Very important. So energy consumption by refrigeration equipment can be reduced by 2 to 4%. Sorry. If the set cooling temperature can be increased by 1 degree Celsius. Set the temperature based on temperature recommendation. Ensure the X-ray machines, film processors, and other significant individual pieces of equipment are switched off when not required. These are very important, because this is not continuously used. Whenever the demand, you have to switch on. Because in the modern type of digital X-rays and all, there is no need of pre-heating or pre-owning it. Another one is medical gases, where medical gases are supplied in bottles or other storage vessels and connected to manifold systems. They have a negligible impact on energy use. However, medical compressed air, medical vacuums, and anesthetic gases for scavenging all use pumps and compressors, which consume significant amount of energy. So we need to check these equipments. Selecting plants and equipment use all life costing techniques we have to consider. Monitoring, but not controlling, plant operation by a building management system to identify unexpected usage of highlight possible problems. Providing localized systems for applications such as dentistry, medical physics, laundry, and sterilizers to minimize distribution energy and potential leakage. Another one is sterilization and disinfection. To operate effectively, sterilization and disinfection departments requires equipment that is particularly energy intensive. Packaging areas need to be kept particularly clean. The ventilation to this department is filtered at a high efficiency particular air, that is HEPA filters, and usually air conditioned. In order to minimize energy consumption, we need to consider using cascade systems where conditioned air from cleanest air flows to mix natural air than to dirty areas. Using heat recovery in these areas of heat is often emitted 24 hours per day. Choosing sterilized and disinfecting equipment on basis of energy use as well as the performance, energy use, and whole life cycle. And insulating insulators like our autoclaves and all, and connections, flanges, walls, etc. are very important. Metering the department on each utility and specifying individual energy metering for each major washer and sterilizer. Another one is motors and drives. These are very important because these are we will not see where it runs, but possibly if it is not used, it will be running always. So these are running out of sight. Sometimes constantly, every day for a year. The value of electricity consumed by an electric motor over life is typically 100 times of purchase price of the motor itself. It is therefore important to ensure that motors are efficient as possible. Considerable energy savings can be achieved by good system design and to minimize the motor load. A small increase in duct size or pipe size can significantly reduce system load and thus greatly reduce the fan and pump power requirement. So now we will move to another slide, which is building envelope. This is very important for our HVAC system. Identifying and repairing problems quickly can help avoid expensive problems later. The temperature difference between inside and outside is very important. The insulation properties of building envelope, the amount of fresh air entering the building, either with controlled ventilation or through poorly fitted windows, doors, or joints in walls. Improving building envelope in a hospital makes good sense for many reasons. It gives you better temperature control, enhanced patient comfort, improved productivity, lower capital expenditure, a brighter and cleaner environment. These are important factors if you have a good efficient building envelope. And another one is you need to undertake regular maintenance in your envelope, building envelope. Establish a housekeeping schedule for that. You need to utilize the service of thermal imaging from your building so that you can identify the leakages there. So, and also you can fix your schedules for maintenance. Regularly check the building for dampness and moisture damage. Check and maintain insulation. Make the most of curtains and blinds. Improve glazing. Install more insulation during refurbishment. Because as I said earlier also, in a lifetime of a building, you may come up with around 10 times, you will come up with refurbishments of repairs. So you can have a good installation put say during that time. And now we will discuss some combined heat and power system for big hospitals. There can offer an economic method of providing heat and power, which is less environmentally harmful than conventional methods. It is the simultaneous generation of heat and power in a single process, which usually burns fossil fuels such as natural gas or fuel oil to generate electricity on site. At the power station, the heat generated and electricity produced has to be dissipated via cooling towers, which CHP. The heat is recovered on site. The used for space heating and hot water. This means that overall the process is more efficient, so less fuel is used. To gain maximum benefit from CHP, the system needs to be in operation for as many hours in a year as possible for this one. Okay, now we'll discuss combined CHP. If you are not fitted with CHP, you need to consider these points. When to consider CHP is very important. The best time to consider CHP is in existing building is when the heating plant is being replaced, so that the CHP unit can be integrated with the heating system. The commercial value of the electricity and heat produced by CHP unit is greater than the combined cost of the fuel and maintenance required to operate the system. Understand the existing heat and electricity loss is very important. When considering CHP, it is important to carefully assess its application and feasibility. Space requirements should be considered, along with the detailed evaluation of the system engineering, economics, liability, operation, and maintenance. To justify the cost of investment, the aim should be to maximize the use of all the heat and hot water that the system can produce. Every hospital is different, and therefore a detailed cost analysis is very important. And if you have a plan to invest on CHP, so investigate a funding opportunity. If the budget cannot stretch to invest in CHP, explore options for third-party funding. Energy servicing and contract management companies are there. The options can be absorbed the initial cost and risk associated with the installation, maintenance, and operation for the CHP units. Charging arrangements may vary under certain contracts. A hospital may only pay for fuel used by the CHP unit and receive the heat for free, as well as paying a reduced rate for the electricity. And you have to consider the maintenance issue. CHP system requires regular maintenance to ensure efficient operation and reduced risk for background. This is not something like that you fit and forget. So if now we will, this is actually the last slide of my presentation. Now I will present on case study. This is a hospital in Kozhikode district in Kerala. This hospital has been audited. Energy audit has been conducted by Auto Tractions, and we were with them for the implementations too. We have some proposals, and they implemented. They replaced the reciprocating compressors with centrifugal and screw type compressors. They changed all their fluorescent lamps to LED for lighting. Their power factor is unity now. During audit, it was something like around 0.92 and all. Now it is unity. APSC is fitted with harmonic filters to make sure that the quality of power is there, always there in the special critical equipment. Replaced chilled water pumps with IE3 and installed variable frequency drives in the chiller pumps to make sure that the flow is regulated as per demand. Minimized diesel generation of electricity DC by using steam generation. Waste steam used for preheating water by using a economizer, and also they have a recuperator to recollect the waste heat. Installation of VFDs for air handling unit powers and cooling tower fans, which also help them save energy. Inception of solar water heaters and solar power photovoltaics for they have around 100 kVA system installed at that time. Now it has been increased to 350 kVA. So at that time, during 1718, and energy audit was done, it was around 134 kWh per meter square period was the specific energy consumption, and it has been reduced to 1.5 kWh per meter square, something like around 16 to 18 percentage, 14%, sorry, 13 to 14% savings in 1890, and the total energy cost saving for electricity alone was around 18 lakhs, and not given the cost of thermal fuel saved. So this is, and also the comfort level has gone up. So now I conclude my presentation and open for discussion. My email ID is given in the slide. You can contact me for any other this thing. So now you can go for some discussions. So what do you ask?
Thank you, sir. There is a question in public chat box.
Can you speak louder? I cannot.
Okay, sir. Can you hear?
Yeah, now it is okay.
Okay. There is a question in public chat box. There is a lot of energy, but why the current went off so quickly and someone died who was in the treatment? Can they just use another ever available energy source?
Actually, Aparna P is actually she is offline now. This is actually not a relevant question for this particular things, because ധാരാളം energy ഉണ്ട് എന്ന് നമ്മൾ ആരും പറയുന്നില്ല. There is no more energy. What we are discussing is utilizing whatever energy we have, and if they are talking about the redundancy of the system, usually all the critical equipments in the hospitals are fitted with UPSs. UPSs are always n+1 to n+3 redundancy levels. So there is no chance that the power will end off when the source is cut. This is what the wirings have been provided for the modern hospitals. So there will be some. I am not in a position to answer this question, how the patient died, and there will be a lot of other clinical reasons too. This may not be the reasons on energy side. So I think this is answered, right?
Sir, another question. Are there any chances of saving energy by installing waste to energy saving systems?
Are there any chances of saving energy by installing waste energy saving systems in hospitals? Yeah, that is what I have discussed during the presentation too. Because there are number of areas where low heat is ejected, like from sterilizations to the boiler to the DC. There is a good chance to convert this waste heat to useful heat. This actually you can explore most of the heat. I mean, like if you considering heat pumps, lot of hospitals are in use of heat pumps, and also recuperations, condensate recovery. These all are regularly in use in almost all the hospitals. Thank you.
Okay. Thank you, sir, for sharing very important and useful information. Participants, is there any doubt related to this topic? Please use that box.
You have 8 minutes. You can. I think you can switch on. You can allow people to speak also for the 8 minutes, if you give the permission, so that they can talk.
Sir, already the participants use listen only more. That's why.
Okay, okay. Oh, yes, yes, yes. Okay, I understand.
So that's why I ask use public resource. Sir, another question in chat box.
Nowadays, solar rooftop systems are used. Are these made mandatory by the government? How much 5 of energy is saved? Renewable energy obligation is not mandatory for all buildings now, but whenever you are mandatorily have to comply with the ECBC norms, you need to go for all these things. Because in Kerala, we have mandatorily implemented implementing the ECBC norms for all buildings above 100 kW, and it need to be comply all these things. So in that case, there is no specific percentage of renewable energy they are providing, but renewable energy is always taken it as negative side. So for complying the standards, the wise idea or the efficient idea for the management is go for renewable energy. I think almost all the big institutions already tapped this. In our state, in Kerala also, most of the big hospitals have tapped this situation. This SPV with grid-tied system. And for the renewable energy obligation, the 5% REO is for the discoms only, I understand, not for the consumers. Thank you.
Okay, thank you, sir. Is there any doubt? There is a feedback form for this webinar. We will send to your registered email ID and fill and send back to the same email ID.
And I would like to thank Energy Management Center for. We have one last question comes from Srinivas Kumar. If energy audit is energy audit mandatory to be done, submitted by hospitals to government? In Kerala, I will tell you something like some hospitals in India comes under designated consumer category, which is mandatorily has to conduct mandatory energy audit by the accredited energy auditors and submit the form B to Bureau of Energy Efficiency through its portal. That is mandatory in India. In Kerala, all ST, EST consumers has to conduct energy audit. This is mandatory as per government order is from released in November 2011 by the government of Kerala, and it is mandatory in Kerala for all HT, EST consumers. So all hospitals, healthcare facilities comes under HT category has to conduct this energy audit and submit the report to the Energy Management Center. Energy Management Center will evaluate the energy audit report and with a mutual discussion in between the energy auditor, an expert committee, and the consumer, and will discuss all these matters and provide possible suggestions. So this is mandatory in Kerala for all ST, EST consumers. I think it's answered. And also energy audits are going on almost all the hospitals, and they are very eager to conduct energy efficiency projects in the plants. So you can see my email ID in this slide and my mobile number, and I don't know which type of audience this one, basically from the hospital side. So if you are have any doubt, you can post your questions to Energy Management Center, or you can directly post it to me. I will try my best to answer you, because I understand that the presentation in 2 hours went very fastly. Most of the stuff you may have missed, but I know that Energy Management Center will post this video in their YouTube channel. You can visit its YouTube channel and review these things, and you can contact me for any clarification. And I think this is the right time to stop the presentation, and I thank all at the Energy Management Center, especially Mr. Anu. He is not available today, and I thank Mr. Anish Johnson and all their team for inviting me to present this topic, and I am privileged to be part of it. You and hand over to Energy Management Center to wind up this presentation. Thank you.
Thank you, Mr. Suresh Babu, and it was a wonderful presentation regarding hospital sector. Actually, Energy Management Center is conducting this webinar series from June onwards, and we have gone through different topics, and one of our key areas is in the hospital sector, and our accredited energy auditor, Mr. Suresh Babu, has carried out a very good presentation, and it was very fruitful, and I feel that most of the stakeholders are happy with the presentation. And anyway, from Energy Management Center, I thank Mr. Suresh Babu for presenting this one.